Bally 8 Ball. Guy's complaining that there's no playfield lights. And the flippers, he's got problems with the flippers being weak. To me, though, that's the least of our problems. Look at this CPU board. Look at the corrosion on this thing. I mean, the battery's not there, but look at the masking is just kind of like flaking off. Look at this. Look at the big pieces of flake down here. I'm surprised the CPU board runs at all, but the game does run. I mean, he says the game runs. I did notice that this fuse right here is blown. I don't know if you can see you can see it physically, it's blown. This is for the CPU control lights. So I'm gonna pull that out and put one of my fuse things in just to see if it blows immediately. If it blows immediately, then this bridge rectifier up here will be blown. If it doesn't blow, then it was just a bad fuse, but let's turn it on. Didn't blow, that's a good sign. And look, the MPU board is like running. Look, it's flashing. 7th flash. Unbelievable. So sure enough, there are no GI lights. He does have CPU low lights with that changed fuse thing. He's got some score display issues, but on this one, but overall not too bad. But I think the main thing is that, shut this off, is that we got connector pin problems, no doubt. Here, you can see the scorch here, probably on the back side of the board too. So I'm going to pull this board and work on this guy, on this rectifier board a little bit. So I've unscrewed this from the base plate. Right here is the heatsink for the 3 bridge rectifiers right here. And I'm just looking at the pins, the male header pins. I can see a number of crack solder joints I'll need to fix here. Probably add a couple jumpers too on some of the more torched pins. For example, look at this pin. You can see it's kind of black. So there has been some stress on here, and this is probably contributing to the lack of playfield lights. Burnt connectors. We also got to replace, obviously, some of the female connector pins too. Doubled up some stuff, ran a jumper from this outside pin to this inside pin. That basically connects these 2 guys together, which happens on this side of the board, but just because of the board, it's better to do it on both sides. And then on this one too, these 2 pins are connected to the main ground plane, so I just run that jumper wire kind of through the board just to shore that up too. Pull the solenoid driver board just because I like to do kind of my standard modifications on the back. Run the negative on the main filter capacitor to the main ground, link these 2 together, link these 2 5-point test points together. I always do that. Over here, the negative on the filter capacitor for the high voltage, I always like to do that, and then check all the header pins, make sure there's nothing cracked. But the thing that's interesting on this board is like somebody replaced the main 12-volt filter cap with 2 15,000 microfarad capacitors tied in parallel. Talk about overkill. The back of the solenoid driver board, again, these 2 test points together, negative lead of the filter capacitor to the main ground, and the negative lead of the high voltage filter capacitor to ground. So that should, and also check all these guys, the male solder points for the header pins to make sure that none of them are cracked. After doing work on the rectifier board, before you do anything, just connect this one outside connector, leave these other 2 off, power the game on. You won't get any lights when you turn it on, but the game is hot. And then you can check the test point voltages to make sure that you get good voltages. Like here's TP1, DC 6 volts, TP2, DC 100 volts. And the next one is TP3, DC 13 volts. Then TP4 is actually AC, so we got to switch our meter over. Put that there, and you should get about 6 to 7 volts AC. And then the last one's the solenoid voltage, which is TP5, so we should get 45 volts. So we're getting proper voltages across all these test points. Now that you've done that, turn the game off and reconnect the other two connectors that bring power to the whole entire part of the game. Now this connector, I put all new trifurcon pins in. You can see down here, there's the scrap pins. And then this one, on the big orange wire, that's the 12 volts going up to the solenoid driver board. And then these two outside thick wires they all get trifurcons. So I can plug that on like that, and then plug this one on. Okay, so then we got these plugged in. Got our solenoid driver board installed. Always power up with the CPU board connector off, and then we can check voltages on here. You want to check the two lower test points here. Make sure they're 5 volts. The upper one should be about 14 volts. The test point over here should be about 175, 880 volts. And then after all those things are verified, then you can hook this up and boot the game. Again, I've got this connector off, and we can turn the game on. You can see we have lights now, playfield lights, where we didn't have that before, which is a good sign. But I want to check voltages. I want to check the 2 test points up here. They should be the same, 5.1 and 5.1. And then up here at this top voltage, you get about 15 volts, and we do. And over here on the high voltage, we get about 175 volts, and that's adjustable through that little pot. I want about 175. So all the voltages are checking out there. I can turn the game off. I can reconnect this guy here, and then we can watch the LED flash. If the game is going to boot, it will boot now. 1, 2, 3, 4, 5, 6, 7. All right, so we've got CPU control lights, we've got general illumination lights, and we've got lights up here. So one of the playfields complain about weak flippers. 2 problems: loose base plate, that happens a lot, but look, this bushing here is loose too. It causes the flipper to wobble. Fix that. Looking under the playfield, this coil was replaced. I found that in the bottom of the game. Doesn't work on test. I suspect it burned up and somebody just put a new coil in and didn't really fix the problem. We'll be back up at the solenoid driver board. No, it is black with a yellow line. The return line here, this is power, that's the return. Go up to the board and check out the transistor that drives it. Solenoid driver board right here is the black with the yellow wire. So it's pin 14 of this connector. Put a little mark there, and we'll take the board out and follow that trace to the appropriate transistor. Here's the back side where I marked that 1 pin, which I now marked on this side too. We followed up to this transistor. You can see that there's been some heat stress there. And if I take my meter and test, set the diode function, and I test these, it's hard to do one-handed, but I will attempt it. Well, anyways, what happens is, can't do it one-handed, is that it reads open. I get no reading on the meter, so the transistor is in fact dead, and we'll have to replace that to fix the kicker. In addition to replacing this transistor with a new tip 102, the resistor, which was right here, was also fried. You can see this one, it's all black in the middle. This one was open. This is typical when the coil locks on. It also kind of takes out that resistor, so I had to replace that too.